Today we study a new topic, that is cell, EMF and internal resistance. Also in the chemistry, the chapter called electrochemistry, we have studied the cells, Daniel cells, voltaic cells, etc. For that also I will provide the link in the description. But in physics we are going to study it in a very simple way. So this is my cell, and we know that cell is a device which maintains the potential difference between the 2 points in electric circuit. So this is my cell, a container in which I have an electrolyte. So there inside this, all this is my electrolyte, electrolyte solution. Okay, aqueous. This is in aqueous form. Okay, it is in aqueous form or a solution. Now there are two metal electrodes, this one and that one, and these are called the electrodes. So there are two metal rods which are called electrodes. Electrodes. Okay, and this electrode have one positive and another negative. So let me consider this red electrode as positive P and this blue as negative N. So and both of them are made of metal. So this electrode is made of metallic rod, and one is positive and the other one is negative. So there is an oxidation and reduction reaction in the electrolyte between the positive electrode and negative electrode. So there is redox reaction. Redox means reduction and oxidation. Okay, so redox reaction undergo in the cell. Okay, so whenever there is redox reaction, they will produce a current, and because of that current there will be a potential difference. So there, what will be there? There will be a potential difference. Okay, so this is my shell. So in shell I have the two electrodes, metallic electrodes, which is made of the metals, and one is positive and another one is negative. In fact, this is my positive and this is my negative, but for simplicity let us consider this as positive and this as negative, no problem. And this is my solution, which is called electrolyte. So this is my shell, and in between the positive terminal and the negative terminal there is a potential difference. Understood? Now let us connect there and a resistor between this and this electrode. So let us connect a resistor like this. So this is my resistor R, and we know that the current flows from positive to negative. So the current will flow in this direction. So let the current is I, and here is also I, and this current will come down and it will flow between this electrode and this electrode in this direction. So this is the flow of current I. This current is flowing in the electrolyte. So what are the charge carrier in electrolyte? So the charges which carry the current in electrolyte are ions. Okay, so in electrolyte charge carrier is ions. Okay, but in between this rod and this rod, if I connect a resistor, then there will be a charge carrier as electron. So in electrolyte, charge carrier is ions. Whenever the current flows from this to this, there is a flow of current, and this current is because of the ions. Okay, now the current which is flowing from this electrode to this electrode through this wire is the electron. Okay, the current here is due to the flow of electron, that is in the wire connected between the electrodes. This and this are electrode and this is the wire. The charge carrier is electron. Okay, so in this cell there are two types of charge carrier. One is ions which take place in the electrolyte, and other being the electron which takes place between the wire connected between positive and negative electrode. So this is my what is this? Cell. Now let us go to the EMF. Okay. Now let me go to the EMF. The full form of EMF is electromotive force. Electromotive force. Okay, electromotive force. Now what is EMF is that when I remove this, okay, whenever I remove this resistance, then there is no flow of current between positive electrode and the negative electrode. No current is flowing. But what happens is there exists a potential difference. There exists a potential difference between positive electrode and negative electron. And that potential difference, when there is no flow of current, is called electromotive force. Now, it is not a force, though the name is electromotive force, but this is not a force, it is also a potential difference. Okay, so EMF is not force, it is not a force, it is potential difference. Which potential difference? This is the potential difference between the two electrodes of cell when there is no current flow or there is no current run. So this is EMF. So EMF is potential difference between the two electrodes. So in between these two electrodes there is a potential difference. EMF is potential difference between the two electrodes of cell, this cell, when there is no flow of current through any wire. When there is no flow of current with any wire between these two electrodes, this is my potential difference. Okay, and potential difference and EMF is same. EMF is not a force, it is also a potential difference. Then what will be the SI unit of EMF? The SI unit of EMF, this SI unit is volt. And the notation, okay, the symbol is epsilon. Okay, so this is symbol and that is unit. So this is my EMF. Now let me go to the okay. So if it is EMF, if it is potential difference, then we know that V is equal to IR. Okay, V is equal to IR. Now I said that the EMF and the potential difference is same, isn't it? EMF is potential difference. EMF is potential difference. Then looking at this, I can write E is equal to IR. Why not? Because V is equal to I into R. From which law? From Ohm's law. Similarly, I can write E is equal to IR. Why? Because epsilon, that is EMF, is also a potential difference. Then what is R? What is this R? This R should be the resistance between this and this. Okay, so I will just write this as a small letter r for time being, which is a resistance, where you should write where this R is resistance. Resistance between the electrodes. Okay. So this R is the resistance between this electrode and this electrode. And say which material is present between this electrode and this electrode. The material is my electrolyte. Understood? So this R is the resistance between the electrodes, that is the resistance. This is the resistance offered by the electrode of cell. Understood? This is the resistance between the two electrodes, positive electrode and the negative electrode, and we know that between this and this there is electrode. So this resistance is the resistance which is offered by the electrolyte present between the positive and the negative electrode, and this resistance offered by this electrode is called internal resistance. Okay, thus this resistance is called internal null resistance. Okay, internal resistance is small letter R. So we got the cell, we got the internal resistance. Now next topic, I will tell you on what factors the internal resistance depend. Please make a note on this. The internal resistance depend upon the concentration. Number one, just write the concentration of electrolyte. Number two, it depends upon the type of electrolyte. Okay, it depends upon the concentration of electrolyte. It depends upon the type of electrolyte, and also the internal resistance depend upon the area of the electrode. Okay, so area of the electrode. In fact, the internal resistance, okay, the internal resistance R is inversely proportional to the area of electrode. If the area is large, the internal resistance become smaller. Okay, I will now also give you some hint on this type of electrolyte, that if it is conductivity is high, if the conductivity is less, the types of the electrolyte means that. Okay, some may have more conductivity, some may have less conductivity, etc. So in the next topic, we study internal equation of internal resistance and the circuit equation.